Induction motors are the most commonly used electrical machines. They are cheaper, rugged, and easier to maintain compared to other alternatives. In this video, we will learn the working of a three-phase squirrel cage induction motor. It has two main parts, stator and rotor. Stator is a stationary part, and rotor is the rotating part. Stator is made by stacking thin-slotted, highly permeable steel laminations inside a steel or cast iron frame. Winding passes through slots of stator. When a three-phase AC current passes through it, something very interesting happens. It produces a rotating magnetic field. To understand this phenomenon much better, consider a simplified three-phase winding with just 3 coils. A wire carrying current produces magnetic field around it. Now, for this special arrangement, magnetic field produced by three-phase AC current will be as shown at a particular instant. With variation in AC current, magnetic field takes a different orientation as shown. From these 3 positions, it's clear that it's like a magnetic field of uniform strength rotating. The speed of rotation of a magnetic field is known as synchronous speed. Assume you're putting a closed conductor inside it. Since the magnetic field is fluctuating, an EMF will be induced in the loop according to Faraday's law. The EMF will produce a current through the loop. So, the situation has become like a current-carrying loop is situated in a magnetic field. This will produce magnetic force in loop, according to Lorentz law. So, the loop will start rotating. A similar phenomenon happens inside an induction motor also. Here, instead of a simple loop, something very similar to a squirrel cage is used. Three-phase AC current passing through stator winding produces a rotating magnetic field. So, as in the previous case, current will be induced in bars of squirrel cage, which is shortened by end rings, and will start rotating. That's why it's called an induction motor. Electricity is inducted in the rotor by magnetic induction rather than direct electric connection. To aid such electromagnetic induction, insulated iron core lamina are packed inside the rotor. Such small slices of iron make sure that eddy current losses are minimum. This is another big advantage of a three-phase induction motor. It is inherently self-starting. So, you can see here that both magnetic field and rotor are rotating. But at what speed will the rotor rotate? To obtain this answer, let's consider different cases. Consider a case where the rotor speed is the same as the magnetic field speed. Since both are rotating at the same speed, the rotating loop will always experience constant magnetic field. So, there won't be any induced EMF and current. This means zero force on rotor bars. So, the rotors will gradually slow down. But as it slows down, rotor loops will experience a varying magnetic field. So, induced current and force will rise again. And the rotor will speed up. In short, the rotor will never be able to catch up with the speed of the magnetic field. It rotates at a specific speed, which is slightly less than synchronous speed. The difference between synchronous and rotor speed is known as slip. Rotational mechanical power is transferred through a power shaft. In short, in an induction motor, electrical energy is entered via stator and output from motor. Mechanical rotation is received from rotor. Energy loss during motor operation is dissipated as heat. So, a fan at the other end helps in cooling down the motor. Hope you got a good introduction on the working of induction motors. Thank you.
हाय फ्रेंड्स, आई एम दिनेश गोस्वामी। अगर आपको हमारा वीडियो अच्छा लगा हो तो प्लीज़ सब्सक्राइब ज़रूर करें माय यूट्यूब चैनल